Happy May 3rd. Happy birthday, Mr. Daniel's daughter, Sarah, who is set to graduate from college a week from Friday. It's exciting, huh? Hope everybody had a great weekend. Let's do this quick warm up. It's not too tough today. Hopefully, you can read all that and just press pause now. Go ahead and copy it down and start on it, okay? All right, let's see what we got here. We got a couple diamonds. One is the most popular diamond ever. All those with integrity who have always been doing the warm-ups like they're supposed to think this is the easiest diamond ever. You're going to have a 7 times 6 or 6 times 7 equals 42. 7 plus 6 or 6 plus 7 equals 13. And the reason it works both ways is what's called a commutative property of multiplication and commutative property of addition. You can say addition and multiplication are commutative. That means the order doesn't matter. Not true with dividing and subtracting, right? All right, how about 84 and 19? Hopefully you were able to figure out that the two numbers have a product of 84 and a sum of 19 are 7 and 12. Okay, it's always good to know the 12s if you live in America because we still use inches and feet, and there are 12 inches in a foot. So good to know whether you're going into math or going into construction. Good to know those things. All right, for this kin, where I start here is I see these 3 times with 2 numbers. There's a 3 by 3, so I know that those have to be a 1 and a 3 or a 3 and a 1. Okay. What I do know is there's not going to be a 2 in either of these boxes. So for that first column, I have to have a 2 in that top left-hand corner. There's not going to be a 2 in either of these boxes. It has to be a 1 and a 3 or 3 and a 1. So I have to have a 2 in that last column. It's going to have to be here. And then that leaves that third 2 on this box. It's going to have to be there. Once I have that, the dominoes just start falling, right? 2 plus 2 is 4, plus how much is 5? That's going to have to be a 1. If that's a 1, then this has to be a 3. And 3 times 1 is 3. I got a 3, 2, 1 here, right? I got a 1, 2. What's going to be F in here? It's going to have to be a 3. And does that work? 3 minus 2 equals 1. That works. I have a 1 and 2. What should go here? Should be a 3. And 3 times what is 3? 3 times 1. So I got a 1, 2, 3, 1, 2, 3, 1, 2, 3. And the columns, I got 1, 2, 3, 1, 2, 3, and 1, 2, 3. Okay, looks like it all works. On to the integers. Negative 18 plus 4 is not negative 22. I owe 18, but I have $4. That's a positive, right? I'm going to pay the 4 I have. I'm still going to owe some, but not as much. Now I only owe 14, right? Now here I owe 6 minus, I owe 12, sorry, minus 6. So I spent 6 more. Now, again, I think you've heard me say this before. I've had lots of kids tell me, hey, when you teach the kids how to do integers, tell them to turn all the subtraction problems into adding the opposite. So instead of subtracting 6, I'm going to say plus negative 6. I owe 12 plus I owe 6 more. I owe 18. And again, you would see that on a number line if you started at negative 12 and you subtract 6. I'm going that way, right? Subtract the 6. Here, negative 20 minus 5. I start at negative 20 and I subtract 5. Should end up at negative 25. But these are kind of confusing. All those kids say, turn all the subtracting problems to adding opposite. The first number stays the same. You don't mess with it. But instead of subtracting 5, I'm going to add negative 5. Okay? I owe 20 plus I owe 5. Total, I owe 25, negative 25. Now here I have negative 11 minus a negative 6. Subtracting a negative is like adding a positive. So I owe 11 plus I have 4. I have 4. That's good, but it's not enough to pay everything I owe. I can only pay part of what I know. It's like putting a dent in it, is what I say, right? I owe 11. I spend the 4 to pay down what I owe, and now I only owe 7. Okay? All right, square roots. What is the square root of 36 over 49? Well, what number times itself is 36? And what number times itself is 49? So the square root of 36 over 49 is 6/7. How about 9 over 64? What number times itself equals 9? That's a 3. It's a magic number. What number times itself equals 64? That's 8. 3 eighths. What is the square root of 25 81s? Hopefully you figured out that's 5 ninths. How about 16 over 121? It's not going to be 8 up here. What number times itself equals 16? 4. We got 8. It's the most popular wrong answer. And 121, square root of that is 11. Because 11 times 11 is 121. Okay, the square root of x squared. What number squared is x squared? X squared is x squared. And this is tricky here. What number squared is y to the 6th power? That's actually going to be y to the 3rd power. And think to yourself, let's look at that. Y to the 3rd power squared is this times itself this many times. So it's y cubed times y cubed. What is that? That's y times y times y times y times y times y. That is y to the 6th power. Right? Okay. So hopefully I stumped some of you with that, if not all of you, right? It's good if I stump you. Remember, that first number goes inside the box. And the second number goes outside the box. And now I'm hearing this siren in the background. What's that siren coming from? It's coming. Yeah, do not divide with a decimal outside the box, right? In order to get rid of it, I have to move it over so it's all the way on the right. 1, 2, 3 spots to get it all the way on the right. And remember, if the number outside gets 3 scoops, the number inside gets 3 scoops. I start here, 1, 2, 3. Now what do I do here? Fill in that egg carton. Now raise your hand if you're smart. If your hand's not up, I'm asking you, what would you do if you were smart? Yeah, you're looking at this problem and you're thinking, man, that looks a little confusing, right? Look at all those decimals and 4 decimals and 6 scoops. Rewrite it. How long does it take? 6 into 216 with 2 zeros, so 21,600. Okay, that is the same problem as that, but that looks a lot less confusing. Okay, we're going to have to do that one on the back. 44 divided by, remember the first number goes inside the box. A quarter. How many quarters in 25 bucks? Uh-oh, do not divide with that decimal outside the box. You got to move it over 2 spots here. And I can't find a decimal to move over here. Remember, if you can't find it, it's living right there. Now I go over 2 spots. Got to fill in the egg carton. And raise your hand if you're smart. If you were smart, what would you do right here? Right? Rewrite it. 4,400. That is the same problem, but that looks so much less confusing, right? Okay, we're going to do that one on the back too. Same idea here. The 3.96, 3 and 96 hundredths goes inside the box. The 3 and 6 tenths goes outside. Do not start dividing with that decimal outside the box. Move it over 1 spot outside. Got to move it over 1 spot inside. Do not divide with all those scoops and decimals. Rewrite it. Now this one I can do right here. I have a decimal inside the box, nothing outside. That decimal inside the box, I got to move it straight up. Okay, you guys hear that? Who's that? All right, I'm going to have to pause for a little bit and get this phone call because it's an important person. Okay, pardon that interruption. That was Mrs. Daniel calling to pick me up on the way home, but I'm not ready. I got to finish this video first, huh? Then I can go home. Okay? Oh, you thought I lived there, didn't I? Did you? All right. So I decided I was going to do this one real quick first. 36 goes into 39 one time, right? 1 times 36 is 36. When I subtract, I get a 3. What do I do now? Bring down the next number. Oh, isn't that nice? They were nice to us, weren't they? 36 goes into 36 one time. Now, when I say they were nice to us, what am I talking about? Yeah. Boom. Yeah, I told you, do the warm-up. The homework's easy. Yeah, that's on tonight's homework. All right, so let's go ahead and solve these inequalities. Inequalities means it's not equal. This symbol right here means less than. Remember? Left hand less than. Remember, you can make that symbol into an L if you want and write less. Okay, so remember, it's always going to point at the smaller number, smaller value. So x plus 3 is smaller than 7. I want the x by itself over here. I have to get rid of a plus 3. How do I do that? I use the inverse operation or opposite of plus 3. What's that? Minus 3. But if I do it to this side, I better do the same thing to the other side, right? So I subtracted that 3 from that side. I'm going to subtract 3 from the 7. They cancel out here. All that's left is x. And on this side, 7 minus 3 is 4. So if x plus 3 is less than 7, then x has to be less than 4. Okay, and you could plug it in. Try it. Okay, what's it less than 4? Well, 2 is less than 4. Is 2 less than 4? Yes. Is 2 plus 3 less than 7? Yes. Okay. Now, what's this all about? This is greater than or equal to. Equal to works. So it says at least that big, right? But the x is over here. So I want to get rid of a plus negative 8. How do you get rid of a plus negative 8? Well, a plus positive 8. Or subtract negative 8. And remember, subtracting a negative is like adding a positive. Okay, so I'm just going to say plus 8. But if I do it to this side, I better do it to this side. Okay, now negative 8 plus a positive 8, those are opposites, right? Opposites attract, they fall in love, they run away together. Kidding. All right, so all that's left, they do cancel each other out. All that's left is an x on this side. On this side, I have a 1 plus 8, which is 9. 9 is greater than or equal to x. If you want the x on this side, remember it's pointing at the x. You have to say x is less than or equal to 9. These are the same answers. Okay? All right, now I said I was going to do these on the back, and I lied because I have room to do them here now, huh? Remember, I was going to rewrite that. I did 6 into 21,600. Let's just do it right here. Okay, and over on this side, I have 25 into 4,400. And 6 goes into 21 3 times. 3 times 6 is 18. I subtract. I get a 3. What do I do now? Bring down the next number. And 6 goes into 36 how many times? Well, that's a fact, right? 6 times 6 is 36. Bring down the next number. Goes into 0 0 times. 0 times 0 0. Subtract. Bring down the next number. So I have 3,600 for that answer. On to this one, 25 goes into 44 once. 1 times 25 is 25. I subtract. I get 19. What do I do now? Bring down that next number. 25 goes into 190. Wow, I'm glad I like quarters and count money, right? 25, 50, 75, 1. 25, 50, 75. 7 times 25 is going to be 175. That's going to get me close. And now I subtract. I got 15. What do I do now? Bring down that next 0. And 25 goes into 150. How many times? 6. Okay, all done? Do you want a challenge? Do you want a challenge? Okay, we'll say you're done. And I'm going to give you this to try if you want. I'll give you the answer to this tomorrow. Okay, so we're going to have a 4x4 Ken. Okay, and what's it going to be here? It's going to be 4 times, and that's this rectangle here. Okay, it's going to be 1 minus, and that's going to be this rectangle here, those two squares. And below that, that's going to be 2 minus. It's going to be these two squares. And then I'm going to have 3 squares going down. And that's going to add to equal 9. 9. And that's a plus. All these 3 add together equal 9. Okay. Going over here, I got a L-shaped thing with these 3 boxes is going to be adding to 7. And then these 2 boxes is going to be 2 when I divide. And those bottom 2 boxes is going to be 12 when I multiply. All right. So if you want a little challenge later on today, go ahead and try that out. Otherwise, enjoy the rest of your Monday and have a great week. Have a great month. First day of May, huh? It's the third day, first day of school in May. Have a good one, everybody.